Hello again. In this video, we're going to work on the last page of section 7.7. Let's start with example 4. So if you remember, our 3 rules that we learned on the last exercise is the properties of logs. The first one was log of a times b. Notice on the left side it's 1 log, and that is going to be the log of a plus the log of b. And that is because of the law of exponents. If you had 10 to the x times 10 to the y, we know that we add the exponents. So if you multiply 2 things that are exponents together, you end up adding the exponents. So similarly, when you divide 2 things with the same base, you end up subtracting the exponents. The base all means base 10. That's what it means when you just have a log base 10. And this one is since when you raise a power to a power, you end up multiplying them. Very strange. I realize very abstract, but you do need to get these down. But if you do think about it, it does make sense because logs are just exponents. Okay, so let's go ahead and rewrite the expression in terms of log of x and log of y. So what I'm going to do here is I'm going to use my second rule. So I'm going to call this log of 100 minus, notice when it's 1 log under the multiplication and division, and when it's under the subtraction, you're just talking about the exponents, so it's 2. You can put a 10 there if you want, but you don't need to. And then I can do it again. I can use this as log of x plus log of y, but I have to make sure I put this in parentheses here. So it turns out to be log of 100 minus log of x minus log of y. Interesting. This is on the numerator. It's a plus. These are on the denominator. They're minuses. You could leave it like that, but you actually could figure out log of 100 because we know that's a base 10. So again, what does this mean? This is the exponent of when we take 10 and we raise it up. What's that exponent be to get 100? Or you could just do that on your calculator, but we know that's 2. And so this would be the answer to part A. Part B. I'm going to do the same thing. This time I'm just going to do it all at once. So I'm going to take 0.1 plus, because it's 3 things multiplied together, x plus of y cubed. So by the way, you can figure out this, what power. Let's do that over there. Log, we did this before, of 0.1 equals what? So you could do this on your calculator, or you can say 10 to what power equals 0.1. So what I'm doing here, I'm using the definition of log, meaning y, it's supposed to be a y is equal to log of x, means, different than the properties, there's a 10 here, 10 to the y equals x. So that's the definition. So then I figure this out, I get 1/10, so I realize that x is -1. So this is just a -1. And then we have that log of x. And then you could bring down that 3 using the third property. You know, whenever you have an exponent up here, it's the same as multiplication. And that would be the answer to B. C is a little bit different because it's the cube of the whole thing. So I brought down the 3 just to the y on part B, but here it's going to be bringing down the 3 of the whole thing. So what is that going to be? I'm going to do the same thing, but I got to do this in parentheses because it's 3 times the whole thing, 0.1, plus log of x, plus just log of y now. So we figured out that to be -1. This one we do not know. That's what they wanted. in terms of log of x and log of y, so that's okay. So we can put multiply the 3 in for each, which just does make sense. No, I don't have enough room for D there, but it does make sense. This is the answer, because 3, you could have raised 3 to each first, and then the 3 would be in front of all 3 of those. Part D, luckily, does not simplify. When there is one log over on the left here, notice it has to be under multiplication, division, or a power to a power. 2 logs is when it's addition, to go backwards. So let's go ahead and have you practice this before we go backwards, and try exercise 6. Again, pause, try these, and come back when you're ready for the solutions. Okay, here are the solutions. Actually, here are the answers. Write each expression in terms of log x or log y, or state if it's not possible. So I just did it all in one step, so I realized it's a 2 in front of there, and there's a minus. But if you want to see an extra step there, I will add it now. I'd use the second property. This would be the log of x squared minus the log of 10, and then I bring down that 2. Log of 10, by the way, is 1, because what power? Again, there's imaginary 10 there. 10 to what power is 10? 1. Minus for the subtraction, and a 1 there. This one is not possible. There's no formula on the on the left with subtraction. When you have subtraction, you have to have 2 logs. This one I did in one step, but I will add a step here if you need to see it. I used the first rule, and then I brought down that 3. This one is kind of interesting. You could do this the way I did above by bringing down the 3 first, but I'm going to go ahead and do it this way just to show you that you could do that, which is equal to, make some room, log of x cubed plus log of y cubed, and then you can bring those 3's. But notice how I just did it in my head. I realized that there's x cubed, so that would be 3 log of x plus x y cubed, 3 log of y. Solving. So how would you solve? What I would do is I would give you a hint, write down what log means again, this definition right here. So you can try that, come back when you're ready. Before I go over the solutions, I wrote down the definition. Oh, what is that supposed to be? That's supposed to be an x, right? Y equals log 10 of x means the base is 10. The exponent is y because logs are an exponent, so it equals the inside. 10 to what power equals x? The steps I'm going to use is I'm going to first isolate the exponential, part B is already done, or the log, and then I'm going to get into or out of logs. Whenever we deal with solving equations with exponentials with a variable in the exponent like part A or part B when we have a log. They're just inverses of each other. So let's go ahead and do the first 2 together. So what would this be? Again, pause it right here before you see the solution. Here it is. So I'm going to get into logs. I'm going to go this way. So I have the log. I always like to start with the word log. That's how I do it. Log is base 10. The exponent is the y, right? In this case is the x. So that's what its answer. The exponent, we're always equaling the exponents on the outside, so this is a 0.2. And you could, that one you cannot do by hand because it's not in terms of 10, but you can actually now figure that out on your calculator. What is log of 0.2? So you just type in log of 0.2, you press enter, and you will get an answer. X is equal to 0.69897, depending on where you want to round. Say I just want to round 1 decimal place, so x would approximately be negative 0.7, since that's a 9. Or you come around to decimal places, 3 decimal places, whatever you want. Part B, that's how to solve an exponential. To solve for a log, again, you always have to isolate. This one is not isolated. I would divide both sides by 2 to get that log isolated. So isolate that exponential or that log. You can call this 2.5 if you want, since we're dealing with decimals, or you can leave it as 5/2. So now I'm going to get out of logs. So either get into or out of logs. If you're not in logs, get into them. If you're in logs, you get out of them. So again, there's a little imaginary 10 here. So what I'm going to do is I'm going to put the 10, and the y is the guy alone. The exponent is that 2.5. That equals x. So now I could just do that on my calculator. So the answer is 316 about. Makes sense because 10 squared is 100, 10 cubed is 1,000. Or you can round it just to 1 decimal place if you want, or 2 decimal places would be a 0.23, 3 decimal places 0.228, or so forth. So go ahead and try C. If you have not done so already, pause it and see the solution for part C in a minute. Okay, here's the solution. 600. How did I get it? There's a little imaginary 10 there. So I got it out of logs, right? Because it's in logs. So I realized there's a 10. The exponent is the 3, and the answer is the inside. So then I just solved that equation. Turned out to be linear. If you got D and E, continue on. But again, try one more time. If you did not get it, pause it now. See if you can get D or E. Don't forget to isolate first. Isolate, in this case, the 10 to the x. Subtract 4, divide by -5. Okay, here's the solution. The answer is 0. It does make sense. If you plug in a 0 there, you get 4 minus 5. How did I get it? I subtracted 1 first. That went away. Oh, sorry. No, I didn't. I subtracted 4 first. That went away. Make that look like a 4. And then this would have been a -5. Then I divided both sides by -5. And I got 10 to the x is 1. You can see x is 0 right there. But I went ahead and put it into logs in case you didn't see it. So again, going this way. The base is 10. So I wrote the word log. The base is 10. Right? The exponent is, this is solving for the exponent, is out on the outside alone, because that's what it is. It's an exponent, so that's what we want to solve for. And the 1 is in the inside. Then you could just take a log of 1 on your calculator and you see you get 0. Last chance. Part E. Go ahead and try part E. There's a couple ways to do this. And see if you can solve this and come back when you're ready. Now the left side is already isolated, I realize that, but it would be base 100, and so far we've only talked about base 10. We will learn how to do base 100 on, in the next section. Our calculators, just to warn you, only do base 10. So for this one, I'm going to change this to 10 squared before I start, so I can use my calculator. You can do it without base 10, but then you cannot use your calculator and you would have to do it by hand. But there is a way in the next section. So I'm just going to call it 10 squared, so that would be what? I'm just going to distribute that through, make that 4x plus 6. Now I'm going to put it into logs. Log base 10 of this cubed root equals 4x plus 6. If I use my calculator here, it's but 1.333, or 4/3 if you go to math fraction. Then I'm just going to solve this. I can subtract 6 or divide by 4, but you could just multiply by 3 to get rid of the fraction. Multiply the left by 3, the right by 3. Subtract that 18, and I am done. I could reduce that. Here is the answer. I reduced it to -7/6.